up with the actual class. So we're going to start that by moving through 106, 107, and 108 today. 106 is on step functions. A step function is a function that when you graph it, it looks like this. It starts and stops, and it kind of looks like stairs. So with it looking like stairs, pretty much when you look at this in number form, it says something like this. 2 when x is less than 4. I don't know, I'm just making up things. 3 when x is between 4 and 5, and 4 when x is greater than 5. So usually it's going to be like this, f of x equals. And what this means is when you look at it, you're looking for, okay, the answer is 2 when your x is less than 4. So if it says, okay, plug in 2 for x, then you're going to look at this and you're going to say, okay, which category does this fall into? This one, or this one? Well, x is less than 2, so it's definitely going to fall into this first category. So with it falling into this first category, we can already just tell our y. It's right here. It's listed as 2. So what that looks like when you graph is this. It's saying, okay, if this is x equals 4, if we have our x-axis right here, and maybe our y-axis right here, or even right here, then this is what that step function is going to look like. At x equals 4, or anything less than that, is going to just be 2. So I could probably move this up, and it would make more sense. So something like that. Imagine those lines touch. And then from 4 to 5, then x equals 3, or y equals 3, I'm sorry. Because right here, between 4 and 5, this area right here, then y equals this 3. So then we look at this, and when it's bigger than 5, y is going to equal 4. So if I move this down here, then it does the same thing. So it just keeps going from 5 onwards at y equals 4. So our answer for anything in here, if we plugged in 4.5, we would get 3 out. So that would be our ordered pair. So where this is useful is like in the post office, if they say it'll cost you $5 to ship something less than 2 pounds and $10 to ship something more than 2 pounds. So when you graph a step function like that, it would look pretty much like what we had, just with 2 steps. So if we say, okay, less than 2 pounds, so 2 pounds, it's going to cost us $5. So 1, 2, 3, 4, 5. So anything from $0 to $2 is going to cost us this much money. And then after that, it's going to cost us $10. So anything past this line would be another line starting at 10 and continuing out all the way. Does this make sense?
Wait, where did you get to?
I just made it up.
Can you do one more?
Sure. So if we look at this chart in the homework, let me put it on here real quick.
No, the homework chart part, I got that one because it was like simpler, but.
Okay, so if we say I'm going to give us a function here. So 10, actually, I'll start with the lower number. 2 if x is less than 2 pounds. 5 if x is between 2 and 5 pounds. Sorry, I'm writing this wrong. There we go. And then 10 if x is greater than 5. So we look at this and we say, okay, how are we going to graph this? Well, we're going to say, okay, I'm just going to put LBS here and here too, but it's kind of understood that all the numbers are, and these are dollars. So we're saying this if this. So when we graph this, I'm going to try to scroll. So I'm just going to do the positive part of the axis. Okay. So we scroll up and we say, okay, if x is less than 2 pounds, then it's $2. So if we say this is pounds and this is dollars, and we say, okay, if pounds is less than 2, so this is 2 pounds. So if we're less than 2 pounds, then it's going to be $2. So anything here is just going to be this. So anything like $1 or 1 pound, half a pound, whatever. So we scroll back up and we say, okay, it's $5 if it's between 2 pounds and 5 pounds. So we look at 2 pounds, we count over to 5 pounds, which is going to be right here. We say 2, 3, 4, 5. So it's going to be here to here. And then we say $10 if x is greater than 5. So now we just count to 10. So 5, 6, 7, 8, 9, 10. It's right here. And then we count to 10 over here. So 5, 6, 7, 8, 9, 10. So here, all the way this way. Does this make sense? Another thing that you're going to want to know is, remember how on the number line when we were doing inequalities, we were doing them with open circles and closed circles. Well, you're going to do the same thing here. It fits the exact same way. With this sign, you use open circles. So all of these have open circles. So at every edge, we're going to put an open circle. So here, 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 and down at the bottom one. So that is how you graph this step function right here. So what's up, Jada?
Okay, so on the actual work, number 5, it had gave numbers or whatever, and then it had one sitting beside itself. And I had emailed the teacher, and he was like, I asked him what am I supposed to do for number 5? He said one is a horizontal line and one on the y-axis. And generally, it was stretched from left to right. However, this exercise just want the horizontal line from -5 on the axis to -1 on the x-axis. What does he mean by that? Like, what is he saying?
Let me work it. So I'm going to work number 5. Okay, so let me scroll down.
He spoke in Spanish.
And he said put it in GeoGebra or something like that.
I was just writing.
And how are we supposed to do that?
It's easier to graph step functions than put it in GeoGebra. So graphing them by hand is going to be easier as long as you understand how. So maybe I need to make my dots a little smaller. We'll do
We doing number 5?
that. Yes, we're doing number 5 from the homework.
Yeah.
So number 5 from the homework looks okay. So the function is 1 if -5 is less than or equal to x is less than -1. 2 if -1 is less than or equal to x is less than 3. And 3 if 3 is less than or equal to x is less than 7. So something that you should notice about these down here is that they kind of butt up against one another. So we have -1 is the ending point on this first one, and it's the starting point on the second one. 3 is the ending point, 3 is the starting point. So it's a continuous piece of the graph. We're just doing things at different sections of it. So for this first one, we have to identify this section of the graph. And with this section of the graph, we're looking for, on the x-axis, -5 to -1. So we count over -5. So -1, 2, 3, 4, 5. So I'm just going to kind of put a line there and a line here because that's where this section of the graph is.
So you did mark the +1 on like the y-axis, or did you start?
No, I marked it on the x-axis and that's it. So now, because of this, I'm going to put my line there. I'm going to say, okay, it is +1.
So what is the 1, 2, 3?
The 1, 2, 3 is telling you that's where this +1 came from. That's why this is graphed as +1. So let me move on to the next. Sorry. So let me move on to the second part, and then maybe it'll make a little sense as well. So if we look at between -1 and -3, so -1 we've already found, it's right here. And then 3 is 1, 2, 3 right here. So I'm just putting a little mark just to mark it for myself. So now we do 2. So we go 2, just like that. And then from 3 to 7, we do the same thing. So we've already found 3, 4, 5, 6, 7. So the little mark just for me. And then 3 to 7, we mark at 3 because that is what our function equals in that interval. So now we need to put our open and closed circles. So we have a closed circle over here because it goes with -5. We have an open circle here, closed circle, open circle, closed circle, open circle. So this would be how you graph number 5 for that stepwise function. Jada, does that make sense regardless of what your teacher told you?
I think so. I know what you just said.
So your goal for doing these types of problems, no, it does not. Sometimes you're going to have different things right here, but this is what you follow. So you find your interval using this. So whatever this tells you, you mark it on your x-axis. And then you graph whatever the function is right here. So right here, it just tells you that it equals 1 every single time, no matter what. So you found your interval, which is this to this, and then you graphed 1 because that's what it told you to do at that step. And then you found this interval, which is here to here, and you graphed 2 because that's what it told you to do at that step, so on and so forth. So sometimes it's not just going to be a number. It's going to be something like number 4. With number 4, you have actual functions there for the first and the third one. So if we graph this, I'm just going to draw my graph real quick. So f of x equals 2x plus 3 if x is between -3 and 0, and 3 if x is between 0 and 2, and 4x minus 5 if x is between 2 and 5. Okay. So first we're going to graph our intervals. We're going to find these parts of the graph right here. So we go from -3 to 0. So -3 to 0. And we say, okay, now we need to graph 2x plus 3, which we know how to graph because it's in slope-intercept form. So we graph that. We find plus 3, 1, 2, 3, which is our y-intercept, and we put a dot. And then we graph our slope, which is 2 over 1. So instead of going to the right, I'm going to go to the left just to make this a little easier so I don't have to erase as much, but you can go to the right as well. So down to left 1. So I just graphed rise over run right there. So if we do up 2 over 1, we're going to end up right here, and that's going to fall in the same line. I just did it the other way just to make it a little easier to for when we have to erase in a minute. So now I put a line, and I just make sure the line goes to -3. And we're saying that this function fits the graph. It goes in this little section right here. So we've graphed it, but we don't need to graph the full thing that goes from all the way left to all the way right. We just need to graph it in this little section of the graph. So I'm going to do my closed or open circles right now. So I'm going to look, and it looks like they're both closed circles. So both closed circles. Now I identify my second section of the graph, which is right here. It's this part. It's from 0 to 2. So from 0 to 2, we have the graph equals 3. So we take right here and we put the line at y equals 3. And we put the closed circle because that's exactly what we were doing on the last problem. That's just what it equals no matter what we plug in for x.
So wouldn't it do the -3 and the 0?
Yeah, that's right.
The -3 and the 0 is this section right here. So for -3 and 0, we've plugged in this function. Instead of it just being a number like it was in the last one, it's a function. And we can graph this function just using slope-intercept form. So we graphed it from here to here with the slope of 2 over 1 and the y-intercept of +3. Does that make sense?
Okay, so. Oh.
So, Jada, to answer your question, if it's positive pointed, I go to the left. So if I go up 2 over 1, I end up right here, right? So when I draw that line, it's going to end up same spot. And then I just have to erase it because over here we have a different function that fits the graph. It's not true right here. So we have to erase it just so that way it's only in this section of the graph because that's where it specifies down here. So all it's saying is between these 2 points, this is what you do. Between these 2 points, this is what you do. Between these 2 points, this is what you do. So you're going to have to do some graphing and erasing and things like that to get this to look exactly right. So when we do our second part, like I just did, we do from 0 to 2. So from 0 to 2, and it's just like the last one. We say, okay, it equals 3. So at 3, we just draw our line. And we look for our endpoints, and we're going to use closed circles on both of the endpoints. So for the third section, we identify our interval, which is 2 to 5. So 2, 3, 4, 5. And we say, okay, now in that section, we need to graph 4x minus 5. So minus 5, so that's our y-intercept. So 1, 2, 3, 4, 5. Put the dot there. Then we do up 4 over 1, up 4. That was 1, 2, 3, 4 over 1, right, this spot. So I'm going to put a dot there. Up 4, 1, 2, 3, 4 over 1, this spot. Up 4, 1, 2, 3, 4. I'm sorry, over 1. So now we have 2 points in this little interval. So now we're going to graph that section. So, okay, now I have a graph, but it's not this part of the graph that's outside of this little area isn't what we need. We only need the part that's inside the little area. So I just go back and I erase the part that's inside the little area. And the area is from here to here. So erasing, we end up with this graph. Yes, it is. Well, this is supposed to overlap. But there we go. Does that make sense? If it does not, those are the only 2 graphing problems you have to do on this assignment. And I've just done them for you. So there you go. Okay, so moving on to 107.
Just the bottom part.
Just the bottom part of 107.
I don't know what you do. I did some of the bottom part.
Graphing absolute value functions.
That part, I did number 4. And I did number 7, 8, and 9, and 10.
Okay, so we have questions about 7, 8, 9, and 10. So the easiest way to do these, didn't we talk about this on Monday?
We talked about what you call it? I got the note if you want me to show you. We talked about the parts of number 1.
Okay, so maybe it was the Algebra 1 group. So for 8 and 9, what you're going to want to do is plug in, it says use GeoGebra linked on the task page to solve the next 3 problems. So what you need to do is take 2x minus 6 for number 8. Like the problem is this.
We did 9 together. Yeah, because he came over here. That's how I got 9.
That's what I was thinking.
Oh, never mind. Dang.
I need help.
Let me see.
Okay, so just
5 for real. 5.
I can go through a 5.
Okay.
I did 5.
okay, so number 8, I'm going to go over real quick and we will see how to do it. So for number 8, it says solve 2x minus 6 in the absolute value bars equals 4x plus 4 in the absolute value bars. So the way you do this is you pull up one of the online calculators, Desmos, GeoGebra, Symbolab, whatever you want to use, and you plug it in. And you plug in this side, and then you plug in this side. So I'm going to pull it up right now. Well, maybe. Okay. I like Symbolab because it's going to give you the exact answers as well as the graph. So we search for it, we click on it, and we plug in our absolute value. So there they are, the absolute value bars. So I'm going to plug in the first one, 2x minus 6. And then I'm going to plug in the second one. Actually, I'm going to move outside my absolute value bars, and I'm going to plug in the second one. So the second one is 4x plus 4. And I'm going to hit enter. And it will give me the two answers right here. X equals -5 and x equals 1/3. So that's the answers for number 8. Now you're going to need a graph. And the graph, this isn't very helpful for you because this isn't the graph that it wants. It wants you to graph each of those individually and then give you the graph for it. So for that, I'm going to go to GeoGebra and we're going to graph it like that. Okay, so start the calculator. So here we're going to plug in ABS, which is a shortcut for absolute value, 2x minus 6. So that's the first one. I'm going to hit enter, and it's going to graph the first one. Now I'm going to do the shortcut again, ABS, and hit enter, and then I'm going to graph the second one, 4x plus 4. And this right here this is the answer of what you're actually looking for. So you can copy this and paste it into your homework, and this is what this is what it wants.
Oh, I know, I have a question on one of the homeworks. I gotta look back at my notes. I was confused on like, they'll say x plus x minus negative something. I don't know if you just change that to a plus sign.
Okay, Jada's question is if you have a negative minus a negative, do you change it to a plus sign? And the answer is yes.
And then it was like 1 times x equals, do you just get negative x or do you have -1x? Like, do you keep the coefficient or do you just say negative x?
1x and x are the same thing. So you can change them however you want. You can go between them. It doesn't matter. Okay, so are you guys in person okay on 107? Okay. Are you guys virtually okay on 107? I think there's only 1 or 2 of you. Okay. Moving on to 108. Okay, 107. Writing equations of lines. Yes. 108 is definitely something that we've done, and you guys should definitely have notes for this. Yes. Okay. So 108 is about slope-intercept form and point-slope form and the slope formula. There's a lot to know in 108. Yes, we are. So if you do not have notes, now would be a good time to take them. So our slope-intercept form is y equals mx plus b. And that is usually going to look like this. M and B are going to be numbers. M is your slope, and B is your intercept. So we used this a minute ago. So for this right here, your slope is going to be 2, and your y-intercept is going to be 3. And what this means is when you're graphing the function, it will do something like this. You will find 3 for your, because it is your y-intercept. You'll go up 3, 1, 2, 3, and you'll put a dot. And then you will do rise over run for your slope. So if it's not a fraction, you just put it over 1, because that's the same thing. So now we go up 2, 1, 2, over 1. Up 2, over 1. You can do this once, you can do this 1,000 times. It's going to be the same line no matter what. So there you go. There's your line. Slope-intercept form is going to be the most common form that you see doing this. It's going to be the most common form that things are going to want to be written in. It's going to be the most common form in general. Another form that you're going to see is standard form. AX plus BY equals C. Your slope, negative A over B. And your intercepts are, I believe, C over A and C over B. Let me look just to be sure on this. I don't have notes in front of me. And standard form is not something I use a ton. Maybe. The page doesn't want to load. Okay, so realistically, the most important part of standard form is how to get it to slope-intercept form. And really what you need to remember to get anything to slope-intercept form is slope-intercept form has y by itself. If it doesn't have y by itself, it is not in slope-intercept form. That means nothing multiplied by it, nothing added to it, none of that. It all needs to be completely by itself. For standard form, which is another way that they're going to want it to end up in, you have x on one side and y on the same side. Usually they're multiplied by something. If they're not, it's not a problem. They're going to end up the same way no matter what. So if we convert something that looks like this, 2x plus 3y equals 4, into slope-intercept form, what I'm going to do is I'm going to move my x to the other side. I'm going to move it over here just by subtracting. Minus 2x minus 2x. This is going to cancel. I'm going to end up with 3y equals negative 2x plus 4. Now I divide by 3, and anything I do to one side, I do to the other. So I need to do it to every term. So I end up with y equals negative 2/3 x plus 4/3. Slope-intercept form. Okay, yes.
Oh, no, we're dividing right now.
Where?
What, are we subtracting or dividing?
Here we subtract, here we divide.
Okay, never mind.
To undo multiplication, you divide. To undo addition, you subtract. So, let me get back to the homework real quick. Thank you. Okay, so what parallel means is same slope. So if we have parallel lines, they look like this. well, more or less like this if they were exactly parallel. There we go. Parallel lines, they will never touch no matter how far they go. And all this means is they have the same slope. So this has a slope of 1 over 1. So it rises 1, it runs 1. Same thing with this one. Rise 1, run 1. So our slope for this one is 1, and our slope for this one is 1. So if it tells us a slope and it says, okay, we want to write an equation of a line with the slope of this, or a slope parallel to this, then what we need from that information is we need the slope. And so if it tells us write the equation of the line passing through 2x plus 4 equals y that passes through the point 1, 2. We want a line parallel to this one that goes through this point. So we have a bunch of important information here, and it looks like more than it is. All we need for this part is we need the slope because we want a line parallel to this one. So I go down here and I say slope equals 2 and point equals 1, 2. So now I have two pieces of information in a lot cleaner format than I had before. So I can take, and now I can plug this into what's called point slope form. Point slope form is going to be useful when you have a point and when you have a slope. Y-intercept form is useful when you have a y-intercept, or slope intercept form is useful when you have a intercept and a slope. So this one, it doesn't matter if it's intercept or not, it can just be any point. So our point slope form is y minus y1 equals mx minus x1. So when we plug this in, what it looks like is this: y minus 2 equals 2, because this is our slope, x minus 1. So my x1 came from right here, my y1 came from right here, and my slope, my m, came from right here. So now that we have all these in the correct equation, then we try to get it in slope-intercept form, usually. And to get it in slope-intercept form, we want y by itself. So first thing I'm going to do is distribute right here. And I'm going to end up with 2x minus 2 equals y minus 2. Now I just add my 2 across. Y equals 2x, because these are going to cancel out. And this is in slope-intercept form. So point slope form right here is something that you're going to want to write down. When you have a point and you have a slope, this is what you're going to want to use. It's a good starting place to get you between some information and slope-intercept form or standard form. If it gives you 2 points instead of an equation and a point, it could give you 2, -6, and -2, -4. This is number 4 on your work. So if we do this, we need the slope formula. And the slope formula is going to give us the slope between these 2 points. And the slope formula is y2 minus y1 over x2 minus x1. And this will give us a slope. So when we plug in, I do this, and I say, this is point 1, this is point 2, this is x, this is y. Now I can follow just my chart. So I can do y2, -4 minus -6. So in this case, this would turn into a positive, so I'm just going to write it like that. And then on the bottom, we have x2, which is -2, minus 2. So when we work this out, we're going to get -4 plus 6, which is going to give me +2. over -2 minus -2, which is -4. And this is going to give me -1/2. So we found a slope. And now we have 2 points. So we can use either one of these points, up to you, for point slope form. So I'm going to use the second one. Doesn't matter though. So my point is -2, -4, and slope is -1/2. So from here we use point slope form because we have a point and a slope. So y minus y1 equals m times x minus x1. So y minus -4 equals -1/2 x minus -2. When this works out, we end up with y plus 4 equals -1/2 x plus 2. Now we distribute. We take this 1/2 and we multiply it in. So we end up with -1/2 x minus 1. Y plus 4, we subtract 4, subtract 4. So we end up with y equals -1/2 x minus 5 in slope-intercept form. So for parallel lines, like we talked about, we have, it just means same slope. Perpendicular is another word that is opposite of parallel. Perpendicular means that lines will cross at a 45-degree angle. So, or at a 90-degree angle, I'm sorry. So this, they cross at a 90-degree angle. They're going to cross exactly once, never again. So how we determine this is, let's kind of play with it a little bit. Let's say, let me actually, so if we have up that many over that many, so let's count them. Up 1, 2, 3, 4, 5, over 1, 2, 3, 4. So for this top one, we have a slope of rise 5, run 4. Now let's do the bottom one. So the bottom one is going to, these do not cross at a 90-degree angle. So with my poor example here, this is not going to work out if we do it that way. Let me fix this so that way it will. Okay, there we go. So doing that again, and forgetting I said anything about 5/4, we count up 1 and over 1. So we are at a slope of 1. So if we have this one here, what we're going to have is a slope of -1 because we go over 1, down 1. So it's going to be -1. So if we look at these are perpendicular. They do 90-degree angle cross. And what we have to do to get between this slope and this slope is we have to take a fraction, 1 over 1, and we flip it, which just still makes it 1 over 1, and we turn it negative. So we end up with 1 over 1 negative, or just -1. And this is this. So if we have a regular slope of 1/2, then we flip it, and we make it 2 over 1, and then we make it negative. So that's going to give us a -2 perpendicular slope. So the slope of 1/2 perpendicular to that is going to be a -2 slope. So these problems are going to work exactly like the parallel slope lines. You just have to change your slope from the same slope to a perpendicular slope. So if up here, instead of wanting a parallel line to this, we wanted a perpendicular line. The only thing we would change here is we would take our slope here and we would flip it to be -1/2. So now it's a perpendicular slope. So everywhere here where we plugged in 2, we would plug in -1/2. And it would give us the equation of the perpendicular line. It's the exact same process. You don't have to do anything different after you have changed it like this. Does this make sense? Yes? Awesome. So I think that's the important points on equations of lines. And if you do need extra help, there is the other video that I recorded on this when we went over it the first time that you can reference. So I'm going to let you guys go today. Y'all have a good day, and I will see you on Monday, where we will do our best to catch up.